IP internetworking. This is an important drawing that kind of summarizes most of what we've learned thus far. Don't be freaked out by all the IP addresses. We'll take it just a piece at a time. Notice that this network is divided into two segments. When I use the word network segment, another term for that is subnet or subnetwork. Another term yet is a broadcast domain. Now you see in the upper left, the host has 192.168.1.232 with a 24-bit subnet mask. So in other words, the network ID on this left network is 192.168.1.0. Okay? Now, on the other side of the network, where we have a couple servers, notice that the network ID there is 192.168.2.0. How can these hosts on each of these network subnets communicate with each other? You'll notice that they're locally plugged into a switch. A switch is a layer 2 device that serves, among other reasons, to get your hosts connected to your network backbone. They can do other things, but one thing that most switches, at least pure layer 2 switches, can't do is route traffic from one subnet to another. So you'll notice that each switch is also in turn plugged in to a router interface. That router has a separate interface that's connected to each subnet, and each host on each subnet in its IP configuration is pointing to its local router interface as its default gateway. So the .232 and the .66 machines have 192.168.1.1 as their default gateway, and our .15 and .16 hosts are using 2.1. All right? So the great benefit there is if 232 wants to communicate with .66, the local host is going to take its 24-bit mask and compare the network ID from one to the other. Of course, .232 will see, oh, 66 is on my network, so I'll directly communicate with it. If 232 needs to communicate with .15, again, we're going to use the subnet mask to compare network IDs, and 232 will resolve, well, .2 is not on my network. I'm going to send those packets to my default gateway and let the router figure out how to get there. Speaking of switches and routers, I wanted to show you some real hardware just briefly because we've been looking at a lot of Visio and logical diagrams. These are Cisco Catalyst switches, and at left we have, do you see what kind of port shape that is? Those are RJ45 jacks, aren't they? And then on the right we have what are called SFP ports, which are one-size-fits-all ports. You can put fiber in there, you can put all sorts of different interfaces. And you'll normally do something like a fiber interface to do a high-speed uplink to your router or to another switch. Switches operate on the basis of the layer 2 MAC address, and they know the MAC address of every host that's plugged into each of its ports. This is a Cisco 3600 series router. You'll notice that the router has far fewer interfaces than a switch does. What's neat about routers is that in addition to segmenting a network with physical interfaces like the two you see here, you can actually create sub-interfaces to give the router more routability, for lack of a better term.